Let us see about fixed point and floating point number representation. Now, before that, we want to see what is never finite word length effects. In the design of FAR filters, the filter coefficients are determined by the system transfer function, and these filter coefficients are quantized, truncated while implementing DSP system because of infinite length registers. Only finite number of bits are used to perform the arithmetic operations, and the typical word length is 16 bits, 24 bits, 32 bits, etc. Therefore, in this case of finite word length, it introduces an error which can affect the performance of the DSP system. The main errors are input quantization error, coefficient quantization error, and overflow and round off errors, or it is said to be product quantization errors. And the types of number representation. There are two commonly forms that are used to represent the numbers in digital form. That is fixed point representation and floating point representation. In the fixed point arithmetic, the position of the binary point is fixed, and the bit to the right represents the fractional part of the number, and to the left represents the integer part. For example, 0.1.1100. Here, this is the value that the equivalent decimal value is 1.75. Therefore, 1 is the this is the integer and remaining is the fractional part. In general, the fixed point number n of a design accuracy by the series, it can be represented as n equal to summation of Ci into Ri, where R is the radix. Here, if R equal to 10, the representation is known as the decimal representation, having the numbers from 0 to 9. And if R equal to 2, it is said to be the binary representation, having the numbers from 0 to 1. Here, this is the example they are given below for this the binary number. In fixed point arithmetic, the negative numbers are represented by using three forms, that is sign magnitude form, 1's complement form, and 2's complement form. Now we can see one by one. Sign magnitude form. Here an additional bit called sign bit is added to the MSB bit. That is, if the bit is 0, it is said to be the positive number, and if the bit is number 1, it is said to be the negative number. Therefore, for 0 it is said to be the positive number, and 1 the MSB bit is said to 1. For negative, the MSB bit is set to 1. And the 1's complement form. Here, the positive number is represented same as that in sign magnitude representation, but the negative number is obtained by complementing all the bits of the positive number. That is the 1's complement representation. Here is one of the examples they are shown. And next one is 2's complement representation. Here, the positive number is represented as same in sign magnitude and 1's complement form. The negative numbers are obtained by complementing all the bits of the positive number and adding 1 to the least significant bit. This is the examples. And next one is the floating point representation. Here a number x is represented, that is x equal to m r square, while m is said to be the mandasa, which requires a sign bit for representing the positive numbers or negative numbers. R is the base or radix, and e is the exponent, which requires an additional, and it may be either positive or negative. For example, 278, which is the floating point representation. This can be represented by using 0.28 into 10 to the power 3. This is the representation of the decimal number by using the floating point numbers. Now we can see the comparison between the floating point and fixed point arithmetic. Fixed point arithmetic, it is the fast operation, floating point slow operation. Second one, it is relatively economical, and the floating point more expensive because of costly hardware. A fixed point, it is small dynamic range. Floating point, increased dynamic range. And the fixed point round off errors occurs only for addition. Floating point representation, round off errors can occur with addition and multiplication. And in the case of fixed point, overflow occurs in addition. Floating point, overflow does not arise. And fixed point used in small computers, floating point used in large general purpose computers. That is about the fixed point and floating point representation.